Hey, what's going on, guys? Today is solution day, and we made it through another week. That's that's good. Good job, everybody who is attempting these questions and being proactive about the questions. The questions that I wanted to address today are kind of interesting. This is the one on data analysis, and I wanted to go over one of the questions that was a trig question, and it kind of threw me on a tangent when I started getting some of the responses for these questions or feedbacks. Now, in my experience of teaching international students for 15 plus years, I noticed a significant difference between the North American students versus the Asian students. And the questions that the North American students find relatively easier are more data analysis and graphic oriented, and the questions that the Asian students find quite easy or they're very good at is the identities and equations. Now that I've seen this pattern quite a bit, and the U.S. students, so North American students, they are really good at data. They're really good at looking at data and drawing. They can draw reasonable conclusions from it, even if it has a bit of a gray area. The Asian students, they like pinpoint accuracy. They don't work well with shades of gray. And even though, I mean, there are exceptions, but I have seen this pattern in over 15 years that the American students, they are very good at data analysis and graphs. They will look at a chart and they can draw reasonable conclusions from it. And the questions that the Asian students, they're very good at has to do with equations and identities. So the same questions, some of my North American students, they could not figure out the heads or tails of questions, kind of like the questions like these. And the Asian students, they were just so quick at looking at the equations, and just within mere seconds they could see, hey, sine ax equals 2y, so x squared by z equals a, and you substitute ax plus az plus 30 equals 180, you've got x equals 10 and 15, negative 15. And the same question, because it's just the way the education system works, is that data is more preferred in the North American side, and equations and identities, they are preferred on the Asian side. So the whole education system is kind of weighted heavily towards one side or the other. So like the question for the graph analysis of indifference curve was fairly easy for my US-based students, and they were immediately looking at the graph and indifference curve and figuring out what to do. While as the Asian students that I have, they just could not wrap their heads around the concept. So I've seen this quite a bit. So part of my initiative is to bridge the gap a little bit, so we can fill in some of these gaps and have a stronger baseline for conceptual understanding. So for this question, we have an indifference curve. Now, an indifference curve is a curve that compares two quantities, x and y. It's not necessarily that a point on the curve is like the same amount of x equals the same amount of y. It's different. Indifference curves are comparing two different values of two different quantities together. So at 2 points on an indifference curve, meaning the value of x and y combined at one point is the same as the value of the quantity combined at another point. So in here, x dash plus y dash. Now, think of that in terms of not numerical value, but perceived value. So x dash plus y dash is the same as x plus y. So this is point 1 and this is point 2. So we have 2 points on an indifference curve. Now, why is a curve like this even existing? Now, let's pretend that we are dealing in the Stone Age days of barter trading, where there is no standardized currency, and most of the trades and exchanges that happen has to do with perceived value of exchanged goods. So we're looking at an indifference curve. Now, the word indifference comes from the fact that whether I have on point one, whether I have x dash number of one thing and y dash number of one things together is of the same value as if I had x value and y value at point two. So let's just make it a little more concrete. Let's say I had stamps. Okay, let's say I had, in this case, if I had 100 stamps and 20 coins together, it would have the same value as if I had 80 coins and 80 stamps and 30 coins. So in the days of exchanges where I'm indifferent to 2 points on the graph, I'm indifferent whether I have 100 stamps and 20 coin, it carries the same value for me. I'm just as rich if I had 80 stamps and 30 coins. So 2 points. I'm indifferent to both scenarios, meaning I'm just as rich on both scenarios. That's why it's called an indifference curve. The economics classes, this curve is referred to a lot of things because we don't need to compare two quantities to a standardized value like a dollar sign or dollar amount. We're just trading. So same thing. So in our scenario, we have two commodities. We've got stamps and we've got coins. And it's telling me that at one of these points, let's say this one, the point 2, I have 600 stamps, or a collector. If a collector has 600 stamps, and let's see, this is about 2.5, so let's say about 2 to 3 dozen. So if I had 2.5 dozens of antique coins, okay, it will have the same amount of perceived value had I had, what's here, point 1 is about, let's say, about 200, and let's just make it a little bit more accurate. I think it's about 225. That point would be 225. So about 225 stamps and or about 3.5 dozen antique coins. So we've got 2 points on the graph. So let's just pretend we are in the barter days and the perceived value on an indifference curve of someone who has 600 stamps and 2.5 dozen coins is the same as the perceived value of 225 stamps and 3.5 dozen coins. So I'm just as rich. I'm just as rich on both points 1 and 2. I'm indifferent to point 1 and 2. They mean the same to me. So now, if I were to trade it, now we're in a trading scenario because this is obviously a collector's convention. The indifference curve based on 20 years of data from philately and conventions, blah, 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 plotted, blah, blah, blah. And the curve shows that the collector likely perceives the combined trading value of both commodities together on a point on the curve, same as the combined trading value of the together on the point, another point on the curve. So same thing that I was explaining. And that's what an indifference curve is. Two commodities and the combination. Now, don't think in terms of like 300 coins is the same as 300 stamps is the same as 3 dozen coins. No, it doesn't work that way. It's not an equation. It's not like one of these choices here is probably going to trick you. They have the same value. Like this one, that is an incorrect choice because that wouldn't be an indifference curve. And same thing here, they'll say choice B, the value of 300 postage stamps, same as 3 dozen coins. That's a trick. Don't think of an indifference curve like that. Indifference curve looks in combination of values. So we're in the Stone Age, and we just have the two currencies. We've got two things to trade. We've got stamps and we've got coins. So if I had 600 stamps and 2.5 dozen coins, how much of what I would like to spend to get the amount of another quantity. See, like how much stamps would I spend to get a few more coins? So that's the information you'll get from the graph. So if we start to look at what the question is asking, between point 1 and 2, which quantity is perceived more valuable? So the answer to that question is going to come by comparing the information that is in the other parts of the graph. So it says right here, if you look at it, so some of my US students would actually instantly visualize that when the collection size is less, I value things about equally. I'd be willing to give about 100 stamps, like if I was here at 200 point, I'd be willing to trade in my 100 stamps to get about a dozen and a half of coins. Now that is if I did not have as many stamps. So it's the same as the case in real economics. The people who have more money have more spending power, they have more disposable income, so they're willing to trade more of it, driving the price of that quantity up. Same thing here, I have more stamps, so I'm willing to give a lot more of my stamps for a small gain in coins. Okay, so I can, because I had 600, I can give up to 400 of my coins to get maybe like 400 of my stamps I can give up to get about a dozen more coins. So because indifference curve plots equal value of the combined quantity. So because I'm willing to trade in a lot more of my stamps to get a small amount of coins, which means that at that point I perceive coins to be more valuable. Meaning if you look at the slope, the delta of what's happening between point 2 and point 1, I have a big jump. Okay, 1, 2, 3, 4, about 450 stamps I'm willing to trade in to get about a dozen more coins. Now that case wasn't true when I had less of one quantity. So when I had less of one quantity, meaning at this point, this particular point, to go back, if I had 200, I gave up all 200 to get about a dozen and a half, about 2 dozen. So that was about equal value before point A, but as I gain more and more stamps, I start seeing that coins are more valuable to me. So if you think in terms of barter trading days, the coins are perceived more valuable between point 1 and point 2, and this was one of the things that some of my US students, they instantly figured out by looking at the graph, while some of the Asian students, they felt like there wasn't enough data in here, because quite frankly there isn't enough data, but we're working with reasonable conclusions here. And that's why economics deals with a lot of curves that are indifferent curves where you're comparing two commodities. So that's that. So I hope that was clear. My explanation was clear enough. If you don't find it clear enough, just feel free to message me. But the answer to this kind of indifference question comes by looking at the slope of the 2 points, how much of what you're giving. Okay, from going from point 2 to point 1 or some point in between, I am willing to trade in a lot more of my stamps to get a fewer amount of coins as I did before point 1. Okay, so that happens. It's quite common with indifference curves. As you gain a lot more of a quantity, the more valuable quantity surfaces above on its own, because the curve sort of flattens out as more and more experience goes into the system. So that's that. So the correct answer for that would be the antique coins are more valuable between point 1 and point 2, and that's because of choice D. A collector is more likely to trade more stamps for a relatively smaller gain in coins. So that's how you deal with the question of indifference curves. So indifference curves and sometimes confidence intervals, these are kind of strange graphical concepts that almost don't exist in the Asian side of the curriculum, and they exist on the Western side of the curriculum. So that also explains why there is such a gap. Same thing, questions like scatter plots, the questions of scatter plots, they have same kind of effect. The US based system heavily favors these kind of things, so that will help bridge the gap. So for the question, the trig question, the trig question was fairly straightforward. You had to rearrange the exponents and use the sine rule. So the sine rule, if you remember, you've given a 30-degree angle and about 1/4 of the side here. So sine 30 divided by 1/4 should be equal to sine of ax degrees divided by y. So that is something that someone who is really good at equations will immediately see, that sine ax equals 2y because sine 30 equals half. So this system, this side will turn into 2y equals sine ax. Okay, so something the equation dominant curriculum will see almost instantly, and then you substitute the value in here, you get a equals x to the power 2y divided by z to the power y, and the power 1 to the power y. So this thing becomes, because the y will cancel out, this becomes x squared equals az, and we know that it's a triangle, so ax plus az, which is now x squared, plus 30 equals 150, so it's equals 180, so you're looking at 30 equals 180 because it's a triangle. Now, it's telling us that the stability factor is 5, so the equation now becomes x squared plus 5x, and this side will become minus 150. So you instantly see that the value of x is either 10 or negative 15. Sorry, 15. If you factorize that, that will be 15 minus 10. So the x equals 10 or negative 15. So that is also something a algebra-heavy student will see within seconds. So that is where you want to get to, where you can manipulate the exponents so quickly that the answer comes and appears within seconds. So if the value of x is 10, the value of 5x, which is basically our angles, would be 50, and that's your choice given here, 50 and 100. 10 square would be az, so that would be 100. So 100, 50, and 30. So choice C is our correct answer, which means the angles of 30, 50, and 100. So it'll come with practice. It just falls in the same domain as subject matter expertise versus true genius. True genius can be developed. True genius comes from looking at data and data patterns. The more you expose your mind to different kind of questions, different kind of scenarios, that the more your mind will learn. Instead of tunneling into subject matter expertise, try to expose your mind to multiple different types of questions. And also part of my initiative is to combine so many different concepts together that it will help you develop that true genius. It just comes out internally, and something you can develop. So I hope my explanations made sense. Please send me a message if they didn't, and if you want a particular question answered from the last or previous series, I'll be happy to make a video on that or send you a personalized email. Thank you once again, and thank you for supporting Varma Schooling. Have a good one. Bye-bye.